Hello, my name is Ben McGahee with McGahee Mathematics. Welcome to this video on compound linear inequalities. So we're going to learn how to, solve more than one linear inequality. And we have to look at this with, like with everyday English, statements or sentences that we use with a couple of conjunctions. And so one that we use every day is called the and, right? And so, and then the other one's called or. So these are the conjunctions that we take to make a compound sentence, right, or a statement. And for the and, you have to actually get both inequalities have to be true. So both have to be true in order to be true or to work. With the or, you could just have one be true, one be false. So it's just either or can be true. To work, but if you have both of them are false, that's the only way it works, false. And going back to the and, if one of them is false, then the statement's false. So for and, you have to both of them have to be true for the whole statement to be true, and then for or, either one can be true for the statement to be true, either or. So let's see how this works with an example. Let's say you have x minus 3 is greater than equal to negative 1, and we'll do and x minus 3 is less than or equal to 4. So what we'll do here is we will solve for each of these inequalities separately and then see what happens when we graph it on the number line. So solving for it over here, we have x minus 3 is greater than or equal to negative 1. So we just add 3 to both sides. So those will cancel, and then we have x is greater than equal to negative 1 plus 3 is 2. So x is greater than equal to 2. So we'll save this part of the answer, and then we'll work out the second inequality. So we have x minus 3 is less than or equal to 4. And we just add 3 to both sides, and those cancel. So we have x is less than or equal to 7. Okay, so we have x is greater than equal to 2, and we write and x is less than equal to 7. So let's see how this works. So we know that both of these have to be true. X has to be greater than or equal to 2, and x has to be less than or equal to 7. So if we were to graph our number line here, let's say I have 1, 2, 3, 4, 5, 6, 7, and we'll stop at 8. So if I were to say x is greater than or equal to 2, when I graph this, I color in 2, and I shade everything to the left, right? And I make sure to include my infinity, right? Negative infinity. So remember to include those guys when you're thinking of interval notation. So 2 all the way to infinity for this part. And then we use another color. For x's less than or equal to 7, we'll color in 7 because that include that value. And then it's less than or equal to, going this way all the way to negative infinity. So now we just look at where these two colors meet, right? Where did the blue and green meet? So they actually meet between the 2 and the 7, right? In this area. So all these numbers here. So this would be our solution, right, on the graph. So it would be between 2 and 7. And so the way we can express this in the interval notation is that since both of these values are included, we're going to have a closed interval for brackets. And we include the endpoints, right? 2 and then 7. So this all the values between 2 and 7 and including 2 and 7 will be our closed interval, 2, 7. So that's our solution. Okay, so now let's get we'll do a new board here for our next problem. And let's try this next one here. This one is, we'll say y plus 2 is greater than 0. And then we have or, so we're using the conjunction or y minus 5 is less than negative 12. So this time we're using or, so this is a little bit different. So what we're going to do is we're going just to solve for both of these inequalities. So we just subtract 2 both sides. Let's cancel, and we have y is greater than 0 minus 2 is negative 2. So we'll save that one. And then for this one, we just add 5 to both sides. Cancel. So then y is less than negative 12 plus 5 is negative 7. Save that one. So now we're going to draw our number line. Okay, so we'll have like 0 here, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, and negative 7. And we'll just go out this way. 1, 2, 3, 4, 5, 6, 7. And remember to include our negative infinity and positive infinity from the far ends of the number line. So let's graph y is greater than negative 2. So we'll find negative 2. It's going to be an open circle because it doesn't include that value, negative 2. And then we shade everything to the right to positive infinity. And then we also have y is less than negative 7. So that will be, use this color. Y is less than negative 7, so we don't include that open circle. And then shade everything to the left. So since this is an OR statement, we don't have to worry about, whether or not they meet, because you can see that they don't really meet, right? Because you have one that's going this way, and then the other one's going that way. So here, for our solution in interval notation, we're going to start the far left, and we're going to have we'll start at negative infinity, and then that's parenthesis, and we come all the way up to negative 7. We stop. That'll be open parenthesis. And then we notice from here that we have another interval to consider, right? So what we're going to do is we'd have this symbol called union, where we union, or this means or, and then we start at negative 2, comma, all the way to infinity. So when you use the OR statement, you're usually going to have a using the union. So you're going to union two intervals together. So start from very left, we go negative infinity all the way to negative 7, and then we do OR, the union, and then we go negative 2 all the way to infinity. And that would be our final answer in interval notation. So, again, this has been McGahee with Compound Linear Inequalities. Hope this video was helpful for you. Just remember, keep in mind what conjunction you're using, the and or, and that will help you determine your final answer. And do stay tuned for the next video, which will talk a little bit about graphing, some points, and talk about the plane and even graphing some lines. So we'll do that here coming up.